Hello and welcome back to the next video in this series. Today we are going to be utilizing Raster Calculator to calculate a proxy for radiation called Northness. If you recall in our last video, we used a GRASS tool called insol time to create this layer of radiation in watt hours per meter squared per day. Today we're going to use just slope and aspect to create a proxy for that, where slope and aspect get combined into just one metric. That ranges between -1 and 1, where -1 is more solar slopes and +1 is more shaded slopes, sort of equivalent to south and north facing slopes. This is developed by Dozier and Frew in 1990, and it is the sine of slope times the cosine of aspect. So to do that, we are going to go ahead and use Raster up here and go to Raster Calculator. Go ahead and open that up and you will see your raster bands, your result layer, and your Raster Calculator expression. So I'm going to start in the results here and I'm going to save it into my working directory and call it Northness. The next thing I'm going to do is just be sure that my output is going to be in the correct coordinate system. So I've got UTM zone 13N, that is correct. That was what we were looking for Colorado. The next thing I'm going to do is make my raster expression. So remember, it is sine of slope times cosine of aspect. So in order to do that, I'm going to do sine of double-click slope to add it in. And recall that slope is in degrees, and we need to make this into radians. So I'm going to multiply by 3.14159 divided by 180. And this converts it to radians. I'm going to multiply by cosine of aspect, so double click, and repeat 3.14159 divided by 180, and go ahead and close that parenthesis. And you'll see when I close that parenthesis, the OK becomes highlighted. That is your indication you have a valid expression. Go ahead and press OK to run it, and it will create this layer. I'm going to change the symbology by going to properties, single band pseudo color, and I'm going to make it the same as that radiation one we just did. So it looks relatively similar. They are on different scales slightly, but it shows you where the spots are that are most solar in yellow. Let's take a look at our results to make sure that it worked. The first thing to do would be to go to properties and calculate our histogram. Let's take a look at our minimums and maximums. Remember, we cannot exceed -1 or 1, which we have not. We can see our spread looks fairly normal. This is good. We have a wide-ranging landscape that includes all aspects and all slopes. So that all looks good, and it is centered around 0. Remember, 0 is a perfectly flat slope. Okay, let's use the Identify Features tool to explore our data even further. I'm going to click on a north or a south-facing more solar aspect, and we can see that we have a negative value here. That's good. That makes sense. Let's choose a more shaded aspect over here on the backside of Snodgrass Mountain, and you can see it's a more positive value closer to -1. That's good. That means it's working. Let's choose a flat zone down in the valley here, and you can see it's pretty close to 0. There we go. That's a very flat zone, as pretty close to 0. So that's working. Excellent. So don't forget to save. You can compare it to your radiation raster and see what you come up with, but this is a nice way to have a proxy for that. All right, be sure to save, and we'll see you in the next video.